Hola everybody, I am back here with a second example. Notice that this one will not have a slant asymptote because the degree is exactly the same. So this one is not going to have a slant asymptote, but this also is written in quotient form right now. And quotient form is not super helpful to me when I'm trying to find the horizontal asymptote. So what I'm going to do first is go through the process of long division. Okay. So with this long division, it's kind of weird because it's just a monomial of 4x squared. I'm then dividing it by x squared minus 16. You should be noticing something about this binomial, but we'll get there a little bit later. For now, we know to get a 4x squared, we must multiply by 4. That'll get me 4x squared. And then, oh my goodness, that's a minus 64. Okay, but that's just fine. I'll switch it and I switch it. That goes, and I'm left with 64. This then tells me the A value. This will give me the H for the vertical asymptotes here in a second, and then this is K. So I will record transformation form as y equals A over this one. It doesn't look like x minus h, but we'll do something with that here in a second, and then plus K. All right. So the first thing that we know is the K value here, 4, that is what gives me the horizontal asymptote. So that means the horizontal asymptote will be at y equals 4. That is here. But what I'm more interested in are the vertical asymptotes because some crazy stuff is going on with that. So if you notice, this is actually a binomial that we know how to factor. So you're going to factor this difference of squares, x minus 4 and x plus 4, and then you will actually get 2 vertical asymptotes. So we're going to have a vertical asymptote at x equals 4, then we're going to have a vertical asymptote at x equals negative 4. Okay, so I'll graph that, one of them here at negative 4, and the other at positive 4. So now you can see kind of the 3 sections of the graph that have been created. And that's where instead of making 2 tables, we need to identify values here in the left section. We need to identify some values in the middle section, and then we also need to go over here to the right section. So I actually substituted it into the original function that was just in quotient form. I thought that was a little easier to type in my calculator. And once again, if you watched the last video, just like last time, I have calculated those out already, just so that I wouldn't have to go through and type all that in the calculator. The nice thing about these graphs is that there is symmetry, so the left and the right side should be symmetrical because of the kind of quadratic tendencies in it. So let's make sure that that occurs. I'm all the way up here at 19, I guess. I don't know. That's like somewhere up there. Negative 5, 11, 6, 7, 2, 7, 5, 9, 4, 8, 5, 3, 3. So that makes sense because it's going closer, 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 closer to this horizontal asymptote. In the middle section, I just did it at negative 2, negative 1, 3, 3, 0, 0. And then again at positive 2. If you want to do 3 or negative 1, that doesn't really make much of a difference to me. You just need to see the general shape. It's facing down and it is symmetrical. And then over here, I should have more symmetry. Yep, up there at 19. Over at 11. 6, 7, 5, 9, 4, 8, 5, 3, 3. Yep. So this is coming down to catch that horizontal asymptote just like the last one. So the only difference here, after I did the long division, I ended up with 2 vertical asymptotes because this denominator will factor. Okay, so that's it for all the cases of graphing. If there are other questions, let me know, and we will get her done. Thanks, guys. Hope you're having a great day.